Hello everyone, welcome back to my channel. So in this session, let's start with model question papers of network analysis for E&C students. So now without wasting time, question number 1A already discussed and uploaded in my playlist called model question paper network analysis. So let us start with the question number B and question number C now. So now you can see question number B, find the equivalent resistance between A and B. Okay, using star delta transformation. This is a circuit they are given. So now you can see this 4 to B 8 ohm resistor disconnected. You can rewrite, you have to rewrite the circuit diagram. So now let us rewrite the circuit diagram. You can see see now 4 ohm. How we are writing? So this 4 ohm, instead of connecting like that, you have to connect this 8 ohm like this. 8 ohm instead of writing this. Therefore, the circuit which looks like this. Okay, rearranging the circuit. So once after the rearrangement, so I'm just giving some names. So it has a P, Q, R, and this 3 ohm, 3 ohm, 5 ohm, and 4 ohm. Sorry, 3 ohm, 4 ohm, this 3 ohm, 4 ohm, and 10 ohm, 3, 4, 10 are in delta. We need to convert that into star. So that once after converting, we get the value of R1, R2, R3. So how we are converting this to delta, sorry, star, delta into star. To find this R1, adjacent resistors, 3 ohm into 4 ohm divided by sum of these three. Therefore, 3 into 4 divided by 3 plus 4 plus 10, you can get 0.7058. Okay, adjacent resistors. You need to add 3 into 4 divided by 3 plus 4 plus 10. Similarly, to find this R2, adjacent resistors are 3 into 10 divided by 3 plus 10 plus 4. You can get 1.764 ohm. You'll get 1.764 ohm. Similarly, R3 you need to find, that is this resistor. Once after converting this delta into star, you can get 10 into 4 divided by 10 plus 4 plus 3. So you can see R1, R2, R3. So these are the values. You need to find the star connected values. R1, R2, R3 you need to find. So R3 is 4 into 10 divided by sum of the resistors. So now these 3 ohm, 10 ohm, 4 ohm is replaced by R1, R2, R3. Therefore, circuit which looks like this. From A to 5 ohm will be having this 5 ohm to R1, 5 ohm to R1, then R2 to, you can see 3 ohm will go, R2 to 4 ohm, and there is 10 ohm resistor. These resistors will go. The circuit which looks like this. 5 ohm to R1, R2 to 4, R3 here. So that the circuit which looks like this. You can see rearrange the circuit diagram. Okay. See now. R1, R2, R3. So now we have to observe this 5 ohm and 0.7058 is, that is R1 is in series. You need to add these two. Similarly, 4 ohm and R2 is in series. You need to add these two. Then you get some equivalent circuit, so that the circuit which looks like this for that. See, from A, so here we'll be having 5 plus 7058, that is nothing but 5.7058, and there is a resistor R3, the same value of R3. R3 is 2.352 ohms. Then this R2 and 4 are in series, so that if you add that, you get 4 plus 1.764 is nothing but 5.764 ohm. I hope you're getting this. This is fine, and it is connected parallel to 8 ohm, this 8 ohm resistor. 8 ohm. So now we'll be having one resistor that is 6 ohm from here, 6 ohm to here. Okay, the circuit which looks like this, so that you can see the circuit diagram. See, get like this. So once after that, you can see I am marking it as X, Y, Z. So these three are in star, convert that into delta. So now 5.7058 ohm and 5.764 ohm and 2.352 ohm are in star. Convert that into delta. Therefore, you can get the value of R4, R5 and R6. So R4 how will get? Multiplying all these things, that is nothing but 5.7058 into 5.764 plus 5.764 into 2.352 plus 2.532 into 5.7058. If you want to find R4, opposite resistor is 2.35, so that divided by 2.352. So in the examination, directly calculate the numerator value and write it once, that is 59.865 divided by 2.352, you can get 25.452. That is nothing but R4. So these two resistors are replaced by R4 now. Similarly, these two are replaced by R6. Similarly, these two are replaced by R5. So R4 will get, similarly R5 will get, numerator is same. If you want to find R5, numerator value is same, but denominator, that is nothing but 59.865 divided by, if you want to find R5, opposite resistor is 5.764 divided by 5.764 divided by, similarly R6 is, numerator is same, denominator is changing, that is nothing but 59.865 divided by, opposite to this R6 is 5.7058, so that you can see these values. We'll get this value. So now the circuit which looks like this. So this delta is converting into star, so that I'll write for your reference the circuit which looks like this. From A, you'll be having R4 now, R4 just now calculated. Okay. Similarly, R5 will be having here R5 and here it is R6. Once after converting this, you'll get like this R4, R5, R6. And R4 is parallel to 6 ohm. Here we'll be having 6 ohm resistor. And this R6 which is parallel to 8 ohm. So that 8 ohm is parallel to R6. Like this. R4, R5, R6 just now calculated. So that is circuit which looks like this. So now I am writing these equivalent value is nothing but R7 and the equivalent value of this is nothing but R8. Therefore, R7 is nothing but 6 is parallel to 25.452, so that you can get the resultant 4.855. So that from A, R5 as it is, A and B are equivalent, R5 as it is, that is nothing but 10.386. And if you reduce this, you'll get R7 here. This is R7. The value of R7 is 4.855. And if you reduce this, 10.491 is parallel to 8. So if you reduce this, you'll get R8. So that R8 is nothing but 10.491 into 8 divided by 10.491 plus 8. You can get 4.538. This is the next circuit, so that you can get circuit like this. See. So now R7 and R7 and R8 are in series. Therefore, you can get R9. That is nothing but 4.855 plus 4.538. Later, to find R equivalent, this R5 and R9 are in parallel. Therefore, you can get, by reducing this, you can get 4.932. Okay, this is the solution. So if you want, you can take screenshot. Okay, so you need to find this. You can get circuit like this. Then you have to reduce the circuit. First, you are converting delta into star, then star into delta. Then you are reducing the network. simple reduction technique, you can get resistor R equivalent. Similarly, question number 1C, you can see. Question number 1C. Determine V naught using mesh analysis for the network shown below. This is the circuit. So I will rewrite the circuit here. You can get V naught. You need to find the value of V naught. This is a circuit. And I'm just rearranging this and giving the direction of current. I1 is flowing here, and I2 is flowing here, I3 is flowing here. At this branch, I3 you already know that is nothing but I3 equals to 2 into IA for this. Similarly here, I1, you already know the value of I1. I1 is nothing but 4 milliamps. Only the thing is that you need to find the value of IA and I2. Why you need to find I2? Because they asked you to find the value of V0. How will write V0? V0 is nothing but drop across 2 kilo ohm. That is nothing but 2 kilo ohm into I2 you need to find. If you know the value of I2, you will get the value of V0. So that V0 is nothing but 2000 I2 or is 2K into I2. So you need to find the value of I2 now. So I1 you already know, I3 you already know, IA how will write? So IA is flowing here. The I1 direction is same as IA and I2 is flowing opposite to IA. Therefore, IA is nothing but I1 minus I2. Whereas I1 is 4 milliamps. So that 4 milliamps minus I2 is nothing but IA. And I3 is nothing but 2 into IA. Okay, and we're just applying KVL. KVL where you're applying, you cannot apply KVL to loop 1 because you already know the value of current. And also you cannot apply KVL to this loop 3 because you already know current which is flowing is 2IA. So only the thing is that you need to apply KVL to loop 3. That is nothing but apply KVL to this loop. That is nothing but B, E, F, C, D. Here you need to apply KVL. So you already know the direction of rotation. You just give polarity. This is plus, minus, and here also it is plus and minus. You simply mark second polarity and apply KVL. So now if I am marking the second polarity based on the direction of loop, all are minus. Then you are writing minus 1 kilo into here. Minus 1 kilo into which current is flowing? I2 minus, will rewrite. So here current flows to this 1 kilo ohm is I3 is flowing here. I3 is nothing but 2 IA is flowing. So that minus 1K into I2 minus 2 IA. IA is nothing but 4 milli minus I2. Similarly here minus this one minus 2K into which current is flowing? I2 is flowing. Similarly here minus this resistor minus 1 kilo ohm into I2 minus I1. What is the value of I2 minus I1 is nothing but I1 is 4 milli equals to 0. Okay, I2 minus I1. So that if you reduce this, you can get this. So you can see directly as written with reference of this. So others to time save my exam only. So that what I am writing minus 2K I2 2K into I2 minus 2K I2 here minus 1 kilo ohm into I2 minus I1. That is nothing but minus 1K I2 minus into minus plus I1 is nothing but 4 milliamps. Therefore minus 2K then minus 1K into I2 minus I1. That is nothing but I2 is okay. So that minus 1K I2 minus into minus plus 2K into IA. Okay, substituting the values. So that you'll get minus 2K I2 after reducing this minus 1K I2 minus 1K into I1 that is nothing but minus 1K into minus 4 milliamps that is nothing but plus 4 milliamps minus 1K into I2 minus 2IA. Okay, so you can get minus 2 minus 1 minus 3 minus 3k I2 plus 4 again minus 1k I2, okay, plus 2k into I2 minus I1, that is nothing but I1 minus I2. You can get IA is nothing but I1 minus I2, that is nothing but 4 milliamps minus I2. You're substituting this, you can get the answer now. I2 is 2 milliamps. Once after getting the value of I2, you substitute that in a voltage equation, that is V naught equals 2k into I2. A simple KVL you're applying to the loop, then you get the answer. Simplification, you have to do it neatly. Okay. Once after doing simplification, only one unknown you have, you can directly get the answer. Or else you just directly substitute in a calculator. Substitute directly in calculator. You can get the value of unknown. That is nothing but I2 you will get. I2 is nothing but 2 milliamps you get. Then V naught you can get 2k into 2 milliamps. That is nothing but 4 volts you are getting. And this is the solution for module 1, question number 1B and 1C and 1A, which is already uploaded. 1A, which is already uploaded in playlist called network analysis. So practice the problems. These are very simple, and if you want, you can take the screenshots also. So it's very easy to solve the problem. So I hope you understanding the concept. If you're having any doubts regarding this, feel free to write in the comment box, and also share maximum, subscribe maximum. Thank you so much. Have a nice day. Take care. All the very best for your examination.